The big picture idea is that we want to find this inside this how many water we store in these different barriers that we set. And obviously we see is that 1, 2, 3, 4, 5, 6, so a total of 6 of them, and that what you do is basically you sort of use 2-pointer to actually solve for this. I mean for this is so much more talking about talking about the conditional statement that says that you say I have like two barrels, then I'm able to actually trap water. So we're saying that the conditional statement is stating that need the two barriers to be there to actually contain the water. And the bottleneck is the one that is like the shorter one. So if say you got one tall, one short, you're bottlenecked by the short because the water will overflow from there. So with that, it's saying that your bottleneck falls under the shorter length of like the item, right? So that's the conditional statement. You need two barrier, and then you are bottlenecked by the shorter length barrier, and one can also argue that why must you use 2-pointer? You also can use the brute force method to actually try to calculate everything. I mean, if you will see diagram, you do am able to actually calculate 6 intuitively. But if you want a formula, it's so much more about using this one. And how do they actually derive this formula? I think it's very much based on the conditional statement that we've established on top. So between the stage 1 and stage 2 is that stage 1 is saying that okay, minimum L and R is basically referring to that we want the bottleneck of like the shorter length item. And then the next condition is that at the current position, what is your current length? So your current length for the place that you are currently in. So because you need to minus that off with your current length. So say for example this one, say for this one, like sure, I do have like the barrier with a 3 and a 1. We're bottlenecked by this one. But the problem is this, that if my water is here, my current length, the height, current length is actually 2, and here is 1. So water will definitely just flow away from here, and it can't be contained. So therefore we actually do need this current length as part of like the condition. That's why we said over here, right? So that's the relationship between the stage 2 and the stage 1. I don't actually know how the 2-pointer comes in, but and that's the thing that I actually like to actually derive onto. Like if we were to actually see a trend, is that water will tend to be able to the tendency of like having storing of water is always close to the center point of like everything. So that is a very major concern that we like to actually understand why is that so. So to actually discuss this, I think we do need to actually discuss about the edge cases. So if stage A is about the water towards the middle, and then stage B is so much more about the having the water at the edges, right? So why can't I have water at stage B over here? I think intuitively speaking is that if you don't have barrier for left and right side, so another conditional statement that we actually need to actually establish is that uh, there must have two barriers. You know, we actually stated this. So on the edge cases of stage B, we don't actually fulfill that criteria. As for stage A, right, most likely we're gonna have like a barrier for both sides. So that's one important note to actually take note of. Um, and what this links to is because two-pointer uh, have the tendency to actually get um, the two of the pointers, both the left and the right, to start to actually enclose into the middle, which from stage B it tend to go towards stage A, which is a good news because that's where we can actually truly start storing water. But right now we want to actually ask like um, what is the role of having the two pointer? Yes, we are coincidentally we are fulfilling the criteria of like the conditional statement of saying that we are trying to get the two barriers to be working, but at the end of the day, what are we trying to actually establish? I think there's a lot of question marks for this current question that we're actually working on, and that even before we actually dive into the way of how the logic coding does actually work, we have to actually understand the full big picture concept idea of this question itself. Why are we using two pointer? How is the two pointer actually fit the conditions of like every single thing? What is the mechanism that is actually required for this whole entire thing? And what we actually trying to actually fit into the piece is to do with like how does our two pointer actually fit into the picture of these conditional statements. Do I necessarily need to have like two pointer to be able to actually create these two barriers? Or is it just something that to do with like the efficiency to allow us to actually find out the amount of water I can store, right? And I like to actually go down back to the basics of like how the actually the mechanism do work. So currently we are at stage 2. So we are trying to build on stage 1, meaning that we want to actually build more conditions to let us like understand more about what is the conditions that's actually required for this whole question, the mechanism of being able to store water, trap the rainwater as much as possible. So as we see over here, the first water, why no water over here is because it doesn't have the second barrier that is over here to actually trap the water. So this water will not be able to actually trap. So now what's the problem over for the water over here? The water here is that the current height, first and foremost, it's on a very awkward position, and the most importantly is that there's no two barriers at both sides. The left side is empty and water will just overflow. And I'll go to third position. Why water can store here this time now? It's because we have both barriers at both sides, which fulfill the first criteria, and the height difference between our bottleneck short length and the current length has met the requirement, which states that for stage 1, between stage 1 and stage 2 is actually saying that first and foremost, the bottleneck shorter length of 1 is actually taller than our current length, which is 0. So here it's our conditional statement of bottleneck short length, and the current length is 0. And when we have like the short length to be taller than our current length, that will mean that we can store water. That's why we have a 1 unit over here, which is very good. So now we go to the next one. Why water can't store here? First and foremost, do we have the two barriers that actually are helping us? Yes, there is. So that these are 1 unit over here and then the 3 unit over here. And now the second condition. Is our short length taller than our current length? No, because 1 is shorter than 2. Therefore, this thing does not fulfill the criteria. Therefore, water will actually overflow. And we go on to the next one. Do we have 2 barriers? Obviously, we have 2 barriers. And one trend that we are actually looking at is that the closer that we are towards the center area, so this is more of talking about the trends for this whole entire equation. It's pretty much saying that the closer we are towards the center, the more likely we will have the 2 barriers to be actually formed. And we can actually argue the opposite side of things, which is that the nearer to the edges of the things, the less likely we have the 2 barriers to be there. And that will be an issue because we then can't be able to actually most likely solve the problem, what not have you. And when I talk about having closing in, the good thing about closing in is that also that the more likely that I have the number of existence of like barriers for us to actually encounter with, and towards all the edges of the place, the less interaction that we have with the different barriers. And that's another thing to actually take note with, because what's actually important is that we want to have a lot of like interaction with the barriers, so as to have the more likelihood of getting a taller barrier, right? So we call this the barrier length. Right? And having said this, I think definitely when we actually do the pointer, the L and the R, to actually go in, one of the conditional statement is definitely one of the main discussion point is definitely because the number of barrier will be taken care of by itself, so that's fine. So one thing that we can actually make use to actually manipulate is the barrier length. We can use that as part of our conditional statement because this is something that we can control. BA is already taken care of by its own by just having the two pointer to be happening. And enclosing is also part of like the curriculum when we are conducting the two pointer. So it's only this BL barrier length then is something that we can actually manipulate with when we are trying to control the conditional statement for the both the two pointer L and R. So we can use that as like abuse that to use that as the conditional statement for L and R. So for L and R is that for every max length that is like lower, we want to push them in to actually find something that is like taller. So for this very case is that the starting point for here is a 1, and for here the max length is actually 0. So definitely we start moving our L first. And then we reach as a 1. The thing about this is that we do need the length of the item that is on the left side of the current length at the current location, right? So this one is still counted as 0 in my opinion. You move to here, then you say that okay, now I have a value of like 1. There's actually a lot of things for us to actually unpack over here. We're trying to understand more deeply about the question. We're trying to actually learn why the L and R moves inwards. We're trying to unpack a lot of like the items so that in the future we can actually solve this coding part, that the computational part of the left right side. Because if we were to understand the whole concept about this, we can understand the bigger picture of like things that's gonna happen after. Sure, we don't have like much information that we have gone through. Everything comes to an end.